Alguien le está marcando Edgar Josecito.
Mira.
Sí, ahí va. ¿Están chidos? Eso, mira. ¿Cuántos ingenieros se necesitan? Yo no soy ingeniero, a huevo. Pero la pregunta es ¿cuántos ingenieros se necesitan para poder proyectar unos PowerPoints en una pantalla? Cool. Entonces, ¿ya estás transmitiendo, Fer? ¿Fer? O sea, ya oficialmente ya empezamos y sí, la audiencia está como en stand-by.
Ajá.
Ok, chido. Hola a todos, perdonen ustedes el caos. Hace mucho tiempo que no transmitíamos de esta manera en pantallas y cosas por el estilo. Usualmente nada más en una sola pantalla. Vámonos. Es grato tener algo tan moderno y tan actualizado. Y gracias a todos ustedes por venir. Debo preguntarlo porque creo que ¿español está bien para todos? ¿O? Ok, cool, súper. Gracias a todos por venir. Ok, I will try to do English. I don't know. Should we?
No sé.
Okay.
Try pariente.
Okay. It will be different because we usually don't do it because we have online people, offline people. We have Sedano that doesn't speak English.
That's right.
But yeah, we can try to do a mix between them, just to be for everyone. Welcome everyone, welcome to j4G. I'm glad to see you here once again. We're trying to get back to these in-person meetings. We usually do it, well, we have 6 years now.
Yeah.
6 years doing this each month. During the pandemic, we tried to do it. It's English good for everyone because it's also the same, and my English is not good, so. Anyway, thank you everyone for coming. Thank you everyone for participating on j4G. We have been trying to do this every month since 2016. It has been an interesting adventure. We have different speakers of every kind. We have been on different offices. We have been on different places, even in different cities.
That's right.
So thank you everyone. The communities exist thanks to you. The community is for you. It's also important to notice that. So if you're interested in any topic, if you're interested in any place to go, if you're interested to bring us to your local city, well, to local city, that doesn't make sense, right? Well, to your place, to your natal city, or to other country even. We haven't tried. I think that nobody doesn't have a passport, but we can try. We can try. But yeah, the thing is, this is for you. This is for you and for you. We don't make any money from this. We don't make anything from this apart from getting already drunk, and apart from getting Fernando on food. So
Fernando Black.
Fernando Black and Fernando Jaiba, Fernando Veracruz. So thank you everyone. This month we are going to talk about continuous integration and continuous delivery and e-commerce. I know that these are things that sometimes sound like buzzwords, and yes, they are, but we are going to try to keep the hype with the buzzwords, so thank you. Sure. We have 3 speakers, and we have a lot of things in here. We have some rules, so we have to discuss them as they are important. They are the reason we are here. They are the reason that the community has been successful and the community has been growing. So first rule is easy, is respect each other. It is not that hard, just respect each other. That's easy. Like if you don't know someone, you don't have to start making bad comments about that person. It doesn't cost you anything. Also have common sense. Common sense is like, hey, I don't like this chair, I'm gonna throw it through the window. Come on, think about that. It's not that easy. Or I'm gonna drink all the sauce because I want it. Keep it calm, think twice, ask if you're not sure. Keep the common sense. If something is going wrong, if you see something, say something. It's easy. If you see that someone looks pale, or maybe you see smoke, or I don't know, fire, anything, raise your hand or speak out. We're here for everyone, so we don't want to have troubles. We don't want anyone to get hurt or anything. So we care of each other. If you see something, say something. Orly? Yeah, the meetup is for sharing and meeting new people, so do that. But still, try to respect the speaker because there's people trying to bring you, to give you content. So there are moments for talking. Lydia told us that we can stay here until tomorrow morning, so there's no problem. If we have the time first, yeah, she has the key, so. So the speaker is bringing good content, so let's just give a time for the speaker. We have time for knowing each other. We have time for drinking. We have time for having snacks. So try to keep silence while the speaker is here. Try to ask questions to the speaker. Try to comment on the speaker. Try to discuss with the speaker, as it also contributes to others to understand better what is going on. So try to do that. The meetup is for you. You and me, everyone in here is j4G. So that is important to notice. Without you, we are only 3 or 5 people getting already drunk. But thanks to you, we are around 40 people getting already drunk. So everyone is here. Everyone in here is j4G. I don't know what the word. Netherlands? No. Well, that doesn't give you permission to actually go outside, rob a bank, and say, I am from j4G. That's you cannot do that. You cannot go on the internet and say, I'm harassing people because I am from j4G. We don't take responsibility that j4G was here. Yeah, don't go and put graffitis on the street saying j4G. We don't take responsibility for you outside of these offices. And even in here, if we have to take responsibility on you, it can be on both sides. It can be on the good of everyone or on the good of you. So try to don't commit anything that is bad in the name of j4G. We keep, I don't know how to say that in English. I'm going to try to explain it.
Reserve.
We decide who stays and who goes. we take the privilege. Thank you. We take the privilege of saying, hey, you know what? You have to leave. Or saying, hey, you have to leave because we don't agree with the things that you're saying or the things that you are doing. Or we know that you are a bad person on the internet and we don't want you here or anything else. Yeah, so still try to be respectful. Even if someone disagrees with you, you can be respectful. So we reserve that. We reserve the privilege of having you in here. Cool. Yeah. So yeah, sponsors. Who is sponsoring today? The people. The people. No, we are here. If you don't know where you are, we are here at Grid Dynamics. That is the company that is hosting us today. Thanks to Lilia, that she's like the bridge between the community and the company. She works in here, but she has been very supportive on the community since the first day. She has been trying to support us and giving us spaces to discuss, to drink, and get already drunk. Other ones too. If you get drunk, that's okay. But the main course is getting already drunk. People is going to start thinking that it's actually true. That we don't get together to discuss software. We are getting together to get already drunk. But yeah, anyway, thanks to Lilia, thanks to Grid Dynamics. They have been very supportive around these meetups, around these communities. They have been collaborating with us in a lot of different conferences and a lot of different events. So thank you everyone on Grid Dynamics, and thanks to Lilia for being supportive. We are gonna have between talks some kind of interview with the CEO. No, it's not the CEO. It's the Mexican. No, the country head. Country head. Yeah, I'm bad at positions and titles. Yeah, I always say I write code and code goes by. So yeah, the country head is gonna be here speaking with us, discussing. So we will be doing that between talks. So if you want to know more about Grid Dynamics, that will be the time. If you have questions, it's also valid that you ask. So that's it. So about what are we going to discuss today? We have 3 fabulous speakers. We try to bring people that, no, 3. Yeah, there's one online. Yeah, he will be later here in the television. Yeah, we have first Dario Flores. He's from the house. He's a senior software engineer from Grid Dynamics. He's going to talk about applications of big data and machine learning in e-commerce. Finally, we're going to discover what is big data. After 10 years of good works, we're going to finally understand what it means big data and what it means machine learning. We know that Google says that on their conferences, and yeah, we're going to finally discover how do you apply that on a real world scenario. So Dario is going to talk today about that. Next, we will have Dario again. No. Just next. It's freezing.
I think the streaming is freezing. Don't know why.
It's true.
Yeah.
Okay. It's maybe because my computer.
Update the version. No, sure.
Maybe Fair can share his screen. Okay, we will see later. Danny Vega, he's from a software engineer from SoftServe. He's going to talk about Terraform, this thing that helps us to deploy in different kind of clouds using a single thing. Well, I don't know. He's going to talk about that, but yeah, Terraform is a tool from HashiCorp, and he's going to tell us how we can use it to implement continuous integration and continuous delivery using this tool and making it more handsome. Yeah, that's the title of the talk. Cool. Next one is. I see my camera moving.
Yeah, one sec.
You're lying to me. I see myself moving.
It's too heavy. No, yeah, I'm sharing the ground.
Okay. Yeah.
That's right.
Finally, after Danny Vega, I don't know if we're gonna respect the order because Danny Vega is online and Dario is here and the other speaker is here. So maybe we don't put Danny Vega in the middle and we put it on the end, or yeah, I don't know. We will see. Anyway, after Danny Vega, who is gonna be next one? This guy, Jomiel Gomememes. One of our avocados, if you don't know what is an avocado, is one of our top speakers. They always shine by the technical knowledge they have. He's going to talk about hurry up, Goku. The front-end engineer is moving to the GitHub actions and infrastructure stuff. Infrastructure, I always finish with that. The parts of the server things. He's a front-end software engineer. He's an avocado agent. That means that he comes always with great technical content to the A4 community. And also, he works for Platzi. I don't know if you know that company. Well, he works there. Sometimes he does things in there. Sometimes. Other days, he's only, yeah. Other days, he's making memes on the internet. Maybe you know him because he's an influencer. Anyway, last one is just, I like to give you inspiration sometimes. Today is about continuous integration, and anyone can build a fast CPU. The trick is to build a fast system. So that is on you. Try to do that. We're going to have a 3 minutes break while we decide who goes first and put someone on the screen. So follow us in the middle in our social networks. Go for another beer, go for water, and we will go back in 3 minutes. Yeah. Thank you. ¿Se salió? Hacemos el respeto de la sí. Salió a la cámara.
Su silla explicando lo que van a
A veces son medio tronco porque no puedes hacer la silla.
No, puedes conectarte al.
Pasa el link del stream ya. Ellos lo proyectan.
Y ahora, ya me desconectaron.
Si quieres hablar, según voy conectándote, ya está, a ver. Igual si quieres, como estabas antes con el Chromecast, con el Chromecast. ¿Cuál es el HDMI? ¿2 o el 3? Voy a poner el 2. Puse el 2. Vamos a poner el 3. Ahí estás. Entonces, 2 minutos nada más, que se retiren las chelas, que como se van ya. Si tienen preguntas, if you have any questions, raise your hand, ask me. The speaker is for you in here, it's not for other reasons. ¿Con la mía? I try to be as no, me paso de puedes abrir un tab y conectarte a esto. Hoy está muy difícil. Te lo mando si quieres por algún lado. ¿Quieres copiarlo? Está fácil de poner. ¿O quieres lo pongo? Te lo mando. De hecho, mira, más fácil. No. I just want to say also something that I want you to invite. We haven't invited you to this frequently in the past few months, but know each other. Around there is the organizer of the Java user group, Chris. Here is Kasim also from the DevOps community. Here is Carlos Delano, he's drunk. Well, if you're interested, he also do architectural stuff and programming stuff and do know a lot of things on payment systems.
It's partially true.
Partially true. So yeah, know each other, discuss, ask. Don't be shy. No one in here understands what is on the screen, so ask if you don't understand anything. I am the first one to be stupid and don't know what is going on, so I will ask. I ask at the first moment. So raise your hand. Don't be shy. Don't worry. No one in here is judging you. Yeah, judging you. Whatever. No one in here is gonna say anything, and if they do, we are here for protecting you because in here we are everyone to learn together. So yeah. We're just setting up the speaker. If you don't have beer, if you don't have water, you have still time. If you want to go to the bathroom, you have still time. Yeah, that's it. Cool. Eso lo puede hacer el Fer. Pero sí, nada más dale el share screen ahí y puedes compartir lo que vas a estar poniendo. Puedes compartir slides, se permite de Google Chrome, lo de Google Docs, pero puedes compartir de clásico. Sí. Esta previsa.
Los permisos.
Tienes que actualizarla. Quitar el navegador que estás usando. Cerrarlo. No te preocupes. Cuando le abras el sitio ya te va a nueva cuenta. Le está preguntando lo de las tabs. Tengo de voz. Pues para Ya no te preocupes, por lo demás de hoy no haces méritos así. Cool. So we are going to welcome Darío. I ask for you to up for an applause. Yeah. Yes, for an applause. Darío is a little bit shy. So please ask. So he feels more comfortable. Clap at every joke, loud at every serious point, and ask. That's it. Thanks.
Thank you very much, sir. Thank you guys for having me here today.
sharing the
Oh,
to the screen.
Reception. En los displays.
Ajá, creo que es por pestaña y estás compartiendo la. O sea, te pasan los slides. Si quieres, no puedes hacer. Eso lo mueve Fer. Más bien, aquí, dale Trump. Ajá, pero cierra este tab. Ajá, cierra tú. Y ahora dale aquí. Ahí sin mover nada más. Y dale otra vez. Y ya, ahí estás. Ahora sí ya lo vemos ahí. Y acá también. Nice.
hello,
Darío.
guys. Hello, guys. Well, my name is Darío Flores. I am part of Dynamics here in GDL office, formerly Task Knowledge. And a bit of a background about this talk is it's a large story. I am not an engineer like you guys. I'm sorry for that. I'm actually a physicist and a mathematician from United University in Mexico City. Yeah. But there is no money in science here in Mexico. So instead of being in the streets asking for a coin, I decided to start developing software. Yes. And then I discovered that in the development software community, you need people that know a bit of mathematics and statistics and things like that, because there is a huge movement right now about big data and machine learning. And I started working at IBM. I fortunately got fired from there. And I ended up here in Task Knowledge, doing Grid Dynamics, and we started doing e-commerce. And when I started doing e-commerce, I was overwhelmed about the amount of data that we were managing in our e-commerce sites. And then I started taking machine learning and big data online courses, Udemy, everything else. And then I said, well, I want to do this, but I want to do this in the right way. So I enrolled in a master's program. And what I will show you today is the result of 1.5 years of work. And it resulted in my final master's project. So I will start by answering the question that Sierra did at the beginning. What the hell is machine learning? Because Google always talks about machine learning in their conferences. In AWS, Amazon is always talking about machine learning and all that things. Well, what is machine learning? Machine learning is applied mathematics. It's just that, and we can divide machine learning in two major branches. One is giving a set of data, fit a mathematical model in such a way that we can make predictions about new data that comes to us. I will give you an example. You want to have a piece of software that can tell you how much property can cost. Well, we are here in Zapopan, or near Zapopan, And yeah, if you want to buy an apartment here, it is going to cost you $1 million or something like that. And there are diverse factors about that. Geographic factors, I don't know, infrastructure factors. But if you want to buy the same apartment in Tlajomulco, it will cost you one tenth of that. So if you remember, we have this mathematical structure called the vectors. So we can put all that information in the shape of a vector and then make a mathematical function, or try to invent a mathematical function, try to fit a mathematical function to that data, in which the input is, well, the location, the square feet, the infrastructure that is around, and the result is the price of what we have. Machine learning just uses statistical and mathematical techniques also to uncover the structure of certain kind of data that we already have. It is not just like modeling behavior, it's also to uncover what the hell is going on inside of the data. Well, these are the three problems of the machine learning. The first one is the regression one, in which all of the black dots are our set of data, and the red line is the mathematical function that we give as a result of our machine learning modeling. And what we try to do with this function is to try to predict for a certain value of x what's going to be its certain value of y. It is pretty simple. What it is done is what the Tesla cars do. Other thing is the classification, giving a set of data and giving a discrete set of labels, like for example, sick or not sick. For example, in the x-axis we can have symptom, like for example the level of temperature of body temperature, if it's fever or not, and here we can have the level of oxygen in blood, for example, and in that way we can say, well, this is a very simple example. If someone is sick or not sick, has COVID, doesn't have COVID, something like that. And other thing is like the clustering. Yeah, go ahead, man.
The regression be somewhere related to cryptocurrency as well?
To what, sorry?
Cryptocurrency.
Oh, well, yeah, you can try. Well, you can try to model the market with regression, but the number of variables that you will need to do that is like infinite, an infinite number. Yeah, it's been tried. It's been tried. I have tried, but yeah. Other thing is, for example, the clustering. Imagine that this is just X, Y again, but it's a map, a coordinates map, and you want to find like the centers of population, where the population gathers the most, because you want to build a shopping mall or something like that. So you want to find these clusters of where all the data or all the people concentrates, and that is the clustering. And yeah, basically any problem that you want to solve into machine learning falls into one of these three categories most of the time. There is one kind of, there are two kinds of machine learning. One is the supervised machine learning and the unsupervised machine learning. In the supervised machine learning, we have an input of data and its labels. For example, imagine you have a bunch of handwritten digits, and then you have a label that this digit is an A, this digit is a B, this digit is a number 3. And then you put that inside a model that the only thing that it's going to try to do is like try to fit a mathematical function and give you a result. It can be a decision tree, a neural network, or just a normal multi-dimensional function. Then you will have this model set up. You can have, you can put inside new data, and you can have a result about that. This is like the hello world of the machine learning. This is how powerful the machine learning is. The hello world of programming is just writing hello world. But the hello world of programming is like, identifying handwritten digits. This is an example of machine learning that I used in what I am going to show you afterwards. This is a decision tree. This is our, for example, this is our input data. We want to know if it is a good idea to go out and play golf once we sell our startups and millionaires. We want to know if it is a good idea to play golf or not. So our input data is like, well, is it rainy? Is it hot? Is it cold? Mild? Humidity is high, low, normal? How is the wind? True, false? And then we're going to have a decision like yes, no, yes, no, yes, no. And we are going to form this decision tree. And then someday we're going to wake up, and we're going to have a very different set of circumstances, and we will want to know if it is a good idea or not to go out. And we are going to put that new data inside this decision tree, and we are going to have a result. This is the example of supervised machine learning. Unsupervised machine learning is a bit more tricky sometimes, because we just have a bunch of information, and we want to know what is the structure inside of that information. For example, imagine all the orders that Amazon has been fulfilling for one day. What is the relation between them? Are there similarities? Are there some people that like to buy more things than others? Or for example, a supermarket. Everybody goes to the supermarket and buys an avocado, but we buy it for different reasons. There is people that buy an avocado because they want to make a salad and eat healthy, and there is people that buy an avocado because they want to make guacamole and drink it with the beer. Those are like two very different segments of our customer bases, and we want to know who they are, what they want, and that's more or less what the unsupervised machine learning does. In particular, we have this dimensionality. These association rules that we can uncover the relationship between products that are bought together. And this is in which I base my final master's works in the generation of association rules, because I used to handle a lot of order data while we were working on e-commerce here in Task Knowledge. So imagine that we have the orders of one month of Walmart, for example, and you want to know how to recommend certain products, or you want to know what is the relation between beer and diapers, so something like that, because you want to have a good distribution of your store, and your target is to sell more, so that people can find what they really want. Or you want to have these kind of recommendations on your online site. So to create these association rules is very easy. It's a very intuitive algorithm. We just take our order sets. This is just the ID of the orders. This is the items that we have in each orders, in each one of the orders, and then we see which are the products that are sold more. and we define a threshold, a support, we call it. And any product that has a support beyond that value, we just like cut it, and we end up with an item set of the most popular products, so to say, and then we form pairs of these popular products with other products to see how they relate to each other, and we do this in an iteration until we don't find more sets that satisfy the condition of the minimum support value. And in this way, we can find the related products with each other. I just did this until this step because of what I am going to show you later today. Until this step, if you go to Amazon and you open a product, you are going to see this section that says other customers also bought, and that's up until these item sets of two products just. This was machine learning. Machine learning is just like applied mathematics, but yeah, big data is a different beast. We live in a data-driven era, so to say, in which we have a lot of information being generated every day. But what makes data big data? We have always had data. There is information since the beginning of humanity, but now we have big data. What is big data? We have the 5 B's of big data. It has to have like big volume, like for example, the number of orders that Amazon fulfills in one day, or the number of satellites images that are taken per hour. It's in the, I don't know, there are petabytes of images. The velocity in which that data is produced, like the clicks that an e-commerce site receives in 1 hour or in 1 minute. The value, if it is valuable data, can we do something with it? Can we learn about it? If it is variable, if it has some kind of veracity, if it is structured, like XML data, JSON data, or not structured, like for example pictures, and that's what makes big data, or the data big data is this fast pace in which that data is generated, and not only that, is the need of processing that data also very, very, very fast. How do we process big data? Maybe I am too old, too young, but I remember the days before Google. The first company that had this issue of big data, of trying to process this large amount of information with like in a cheap way, was Google. Google, their first objective was to try to index the whole of the internet before the year 2000. And they needed computational resources. But back then, if you wanted like a cluster of machines, your only solution was to go with IBM and try to negotiate a deal with them. But IBM will want to have a piece of the cake always. So Google knew what they had in hands, and they say, well, the technology is not there outside of IBM, so we are going to create our own stuff. So what they did is, okay, what are the biggest computers we can have? Well, the computers from Radio Shack or from Best Buy. Well, let's buy a bunch of those computers and make them work together. And like, let's just create a bunch of commodity hardware and put all of our information in those computers. And they published a scientific paper, actually. They published the Google File System article, and it explains how to take a very large file from the level of petabytes and how to store it in partitions in little machines. Then they needed to process that data, and they released another paper about a technique called MapReduce in 2004, and in that way they were able to process that data, but it was very slow, very slow. And then in 2009, in Stanford, they created something called Apache Spark that had an advantage from MapReduce in the sense that all the processing was done in memory. Think of Redis, but for like data processing. So it was like super fast. And now since 2014, Spark has replaced MapReduce completely. So the big problem of big data can be divided in three also. First, we have a lot of information and we need a place to store it. And for that, we use Hadoop. That comes from the Google File System article. And then, okay, you have the data stored, but now you need to not know what that data has. So you need to query that data. So the community created Hive. It's a tool that sits on top of Hadoop that allows you to query the data in an SQL fashion. And then, okay, well, you have the data stored, you can look inside of it. But, okay, I want to extract some information about that data to gather some intelligence. And that's where Spark sits in. A distributing processing engine to take that data, process it, reduce it, apply machine learning algorithms to it, and gather some intelligence. This is just a brief slide of how Hadoop works. We have a very large file, for example, of the level of petabytes, and we just cut it into pieces. And we just store one of those pieces inside one of the nodes of our cluster. And this is also a very small example of how Spark works. It divides the workload of the calculation between different nodes. So yeah, machine learning is mathematics. Big data is these kinds of technologies. If you are a DevOps engineer, for example, it is going to be super natural, super simple for you to work in big data environments. So okay, that was just a brief summary of what big data is. So what the hell we do with that? Okay, so object recommendations. We need object recommendations in our e-commerce sites. And how I told you, well, the simplest recommendations that we can have is this, like customers also bought something that we have in the product pages. And this is just the application of the a priori algorithm for item sets of site 2. Not all the chart that I showed you, but up until the size 2. And it is a pain. I will tell you why. Okay, so I didn't have access to the Amazon dataset, but in the United States, there is an online Walmart, so to say, an online supermarket that is called Instacart. And back in 2017, they released a huge data set containing 3 million orders belonging to 200,000 customers. All of this is anonymous data. And they launched a competition. So what I wanted to do is that I want to create other customers also bought something. So I applied the a priori algorithm just like that with raw data as it came by, and yeah, I got very funny results. For example, you can go to the alcohol section and see what other customers buy along with the sparkling wine. And it will recommend you, well, yeah, it will recommend you vodka, but it will also recommend you sour cream or crackers and things like that. So yeah, I mean, I applied the algorithm in a correct way. The code didn't have bugs. I hope so. So there should be something missing or something that I should consider in the structure of the data. So I just like look for, well, okay, the first recommended product is the vodka with a purchase frequency of 53, and it was bought by 7 customers, but the other products were like, they have very high frequency, but they were bought by very few customers. So the influential behavior of very few customers, or like the large habits of few customers are like influencing the recommendation. Yeah, man.
What is the frequency? Was it customers?
Oh yeah. So when when the sparkling wine is bought, also the cottage cheese were bought 44 times. So I have all the orders that contains the sparkling wine, and 44 of them contains the cottage cheese, but those orders only belong to one customer. So this customer like, yeah, I like the sparkling wine and the cottage cheese, and I buy it a lot. But yeah, but yeah, but that behavior is like influencing the recommendations. So how do I find this behavior, and how do I filter it? This is just what I told. So we have to take an approach, a mathematical approach, because we need to like manipulate the orders as mathematical objects. So what I do is like I abstract the orders into a vector of zeros and ones, where each of the dimensions represents a product. And if in one of the dimensions I have a 1, that means that product was bought in that order, and I have a 0, that product was not bought. And then I need to know how similar the orders are between each other. There are several ways to know that, but one of the, well, most logical ones is to use something that is called the cosine similarity. If you remember from the school, you recall that we learned about vectors and the cosine that is between each other. So that's the metric that I took to know if two orders were similar or different. Well, by taking this approach, we have certain properties. If all the orders have the same products, then their cosine similarity is going to be 1. And if they have no products in common, their cosine similarity is going to be 0. And any value in between 0 and 1, they are going to have. And then what I did was to take the cosine similarity between that 3 million orders. And yeah, it was a huge calculation. So the number of operations that you have to perform is this one, where n is the total number of orders you have. So yeah, I mean, to be precise, you have 3.5 million orders, more or less. And the total number of operations that you have to perform is this one, 5,902,000,000 that thing. It's an enormous load of computing that you need to do. If you do one operation every 0.000002 seconds, it will take you 135 days. But we have machine learning to the rescue. We don't have to do all of those calculations. We can just do 10% of them, and that will give us some like labeled data, and then we can like classify the remaining ones. So that's what I did. So yeah, this matrix is equivalent to a adjacency matrix of a graph. And when you perform the cosine similarity between just the 10% of the orders, you are going to find that you have this graph and it has like different connected components. There are like subgraphs, independent subgraphs, and you give a label to each one of them. To identify the connected components, you give the label by color here in the image, and even like doing just the 10% of the orders, it will take you like 32 hours. But if you execute it in a parallel process in Spark, like with 16 executors, it's going to take you more or less like 2 hours. Nowadays, you can like create a Spark cluster in AWS or in Google Cloud Platform or in Azure. I use AWS. It was super expensive, but it was to get my master's degree. So yeah.
That's the main feature.
Yeah, I know. So yeah, basically, you end up with a classification model, a decision tree, and the rest of the orders you just pass them through this decision tree, and you get a resulting graph. And this is done like in 5 minutes. So for example, back to these recommendations that we first had for this particular product. This is how the orders graph looks like. Each edge shows the relationship between each order, and the orders of the same color represents orders belonging to the same customer. And what is interesting? Was that a question? No. Okay. So what is interesting is to see this cluster of orders. All of them are of the same color, and they have a huge relationship between each other. So this, is the indication of a customer with very well-defined shopping habits. And this is the one of the few, because there is another one here. This is one of the customers that their shopping habits were like influencing the whole recommendation system. So we want to filter those shopping habits, those particular users. So I came up with the idea of this thing that I call the diversity metric. It's just a ratio of the orders is the numbers related to a single order that belongs to other users between the total number of orders related. So if this value can go from 0 to 1, if I have a diversity value of 0, that means that order only relates to orders that belong to the same customer. And if you have a value greater than that, then it is more diverse. So yeah, I just applied this in Spark. Spark has a plugin that is called GraphX that helps you to manage graph data. And this was the result. It's what we expected. The red orders that belong to a single customer have a very low diversity, because here the clear nodes represent low values of the diversity. Here we also have another cluster, and we just filter that out, and we end up with a smaller cluster with higher diversity. And then I apply another filter that is a filter between the cosine similarity, and I end up with, someone will say, very few orders, but these orders have higher diversity and they are more related to each other. So the quality of the relation between these orders is higher. It's more diverse. It's more what the actual population will want. So I applied So I apply again the a priori algorithm to these orders, and what I get are these recommendations. So what the people tends to buy along with sparkling wine are other kinds of sparkling wine, whiskey, tequila, beers, and things like that. But yeah, but there is a catch. The beer is already a very popular product. People just buy beer because they want it. How do we know it is? Yeah, how do we know if it is related to the sparkling wine? So there is another metric that is called the leaf metric. So imagine the following. Tell me a product. A product. I mean,
Chips.
chicks and you. A what?
Yeah.
Dog? Dog food. Okay, chips and dog food. Chips and dog food. So we have our complete set of orders, and from that 100% of orders, just like 5% of those orders buy the dog food. 5% of those orders buy the dog food. But then I look at the number of orders that buy the chicks, and that's my new universe. And then I say, well, from this now there is my new 100%. 90% of the time that someone buys dog food also buys the chick. So I compare those percentages, and it is given by this statistical equation. Sorry, but it also has this value between 0 and 1, and the higher the value is going to tell me, well, how related is this product actually. How correlated is the action of buying this product with this other one? And then I apply that metric. And these are the results. When someone buys a sparkling wine, yeah, they buy more sparkling wine, tequila, a very special kind of beer. And what troubles me is that they buy this it's not grape juice, cranberry juice. But then I asked my girlfriend, and she told me, yes, of course, because there is a beverage that we girls love that has sparkling wine and cranberry, so it makes sense. And yeah, I have run this for 40,000 products. This is another example. This is roast beef before applying any filtering or things. And if you buy roast beef, it is going to recommend you to buy Oreos and I don't know, wrapped cheese. Yeah. Absolutely. If you apply the first cosine similarity and diversity filter, it starts recommending you, well, salami, bread to do a sandwich, things like that, cottage cheese. And then with the leaf sorting, yeah, it refines it a bit more. It gives you ham, bread, more bread, salsa for your sandwich, a bit, and cheese, salami, things like that. And yeah, if you buy bagels, well, these are like final results also. If you buy bagels, well, yes, buy other kinds of bagels, try something new, or some Philadelphia cheese to spread on them, or some Coffee Mate because you are going to have this on the morning with your breakfast, so you will have some Coffee Mate. Yeah, if you want to buy some pasta, other kinds of pasta, tomato sauce, Parmesan cheese, and things like that. Chocolates that people like to buy, not just one kind of chocolate, they buy different kinds of chocolates every time. Yeah, if you want to have vodka, yeah, what you will need, yeah, tonic water, because we are going to do some vodka tonics, of course. And yeah, grapefruit juice, why not? Thank you very much, guys. data is the process of handling large amounts of data. The technological capabilities that you will need to handle petabytes of data per hour. Data science is like the mathematical theories that you will need to apply to extract information from that data. That's more or less the difference between it.
One question related to implementation of this technology. Have you combined Spark and Hadoop in the same application?
Yeah, just in a bit of, well, not in like in work or for this thing, but yeah, Spark and Hadoop go hand by hand, because in Hadoop is where you're going to have these large files, and you will need to Spark to like process it.
So, yeah, you run the jobs by the CLI or
Well, yes, in the CLI, but it is in the AWS CLI, so to say.
different clusters?
Yeah. There's
Okay, so what you just explained about how Amazon gives you recommendations for everything, but how does it happen? For example, they have millions of products. Is it a bunch of engineers doing kind of the exercise you did, or is it automated? Like how does it come to happen so that when I buy something I see the recommendations? Yeah.
Well, Amazon has this very well refined, so to say. They have been refining these kind of technologies and recommendations for the last 20 plus years. So yeah, I guess they have a farm of servers just dedicated for these things. I mean, this is something that I just did like in a very little amount of data. But yeah, the way in which they handle it, I actually have no idea, but they should have a Godzilla kind of power, of computing power. Something like that.
Well, like an engineer dedicated to that, what does he or she do? Like it's already there. They refine it more, or?
Well, an engineer in this case will try to improve the performance of the algorithms, so to say. But also, what I bet they have is like already they have like feedback metrics of the recommendations they give to you. So that's the recommendations here are like just static, like this product, these recommendations, but they should have something like this product, this recommendation, and they measure how effective those recommendations are. And that's the way in which they have feedback, automatic feedback, and the system does a cleanup of the things that, yeah, probably it's not a good idea to recommend this thing along with this thing, and it's historical data that they have. It's the value of that company.
Can I add something? Usually these big companies have internal dashboards where they see the data. They can extract information in different formats, and they run experiments on there. Like, okay, let's go with the idea and offer A/B testing. Not food, A/B testing. It's yeah. But the name internally is experiments also.
That's what I say.
Okay, A/B testing. Yeah, usually it's like Dario works there, and Dario is saying, okay, I see a trend in here. Let's try to model this as a formula. Let's see what can we apply on it. Let's see the results and see if we can improve this, the current way that we do it with this new way. And they try to read on a sector, on a place, like for example, the formula that applies good for Mexico probably doesn't apply, well, for Mexico City, doesn't apply good for Guadalajara. No. Or maybe the algorithm that they are applying in Indonesia is not the same for the algorithm they are applying in San Francisco. So they are seeing these dashboards all the time, trying to extract the formula, run some local experiments, and then do A/B testing with the results.
Driving Guadalajara, maybe you went south in your grades.
Yeah, exactly. Then maybe you want to drown your breath. So yeah, they do these kind of things. They have specialized teams that are only seeing this kind of data, formatting the data, trying to find correlations as Dario shows on the data, and then applying this to the data internally before actually exposing the results or trying to implement in the real users. We have a question online, and then can go with you.
Actually, a couple of questions online.
Okay, and then we can go with you. Then we'll pass.
Believe it or not, we have people online, like 1 million of people. We have YouTubers right now. Well, the first question is from Alexa Flores. Thank you, Alexa, to be online. She said, so at the end, big data uses to obtain some other data related to the principal and give a more certain prognostic in the e-commerce area translated to recommendation. What? Basically,
Yeah, I mean, big data again is like the technologies that we use to store this and to process this, and then you use the data science algorithms and the machine learning
and
things,
data engineer.
and data engineers, data scientists, and to extract that kind of information. But yeah, think of big data of the technology and infrastructure to handle this. That is very, very complex.
Yeah, I agree. Another question is from Irving. Thank you, Irving, to be online. And well, how do you decide how much to filter out similar data?
That's a very good
Yeah.
question, because you have to play with data. I mean, you have to dare to try something and to see how it results. And that's we have this role, data science. We don't have data engineers, we have data scientists, because they go and they experiment things, and they try new values, they trick something, they change an algorithm and something like that. So yeah, it's not a very straightforward answer to that, because yeah, you need to try a lot of things and to gather experience, and then you apply something, and even then you end up with a rainbow of options, and from those options you just take like the ones that you feel that fits the most. Yeah, that's the tricky part of data. It's not a cooking recipe.
We're gonna move with the two last questions. It's from there and there. I'm sorry, after in the networking, 2 meters or 3 meters you can ask. So
I don't know e-commerce, but it sounds like what we have just said is first we collect data or research, and then we put into their system, and then they will rearrange and generate a report to predict their customer shopping behavior. And then maybe you have some filters, something like that, and then also after that is like you have someone will to reflect the effective of the system, and maybe to rewrite the system to make it more smarter. So e-commerce is the whole set of this process, or a specific part of this process?
Oh no, this is just a very specific part of this. I mean, some people think that, for example, e-commerce is just a web page, but it's not just, because that's what they see. But behind e-commerce, you have the order management systems, the inventory systems, and the like intelligence systems, payment systems, and all that stuff. But yeah, this is just one brick in the wall of the e-commerce. It is just one little piece.
Yeah, and actually it's very small piece of the e-commerce, because you are the one of the, maybe I would say 50 engineers that are software engineers, but you probably are the one data scientist or the one big data specialist in that project, right?
Yeah.
So that is the reason to have a big, that very small piece, but actually it's very, very, very important.
Money.
Yeah, money.
Yeah, it's probably a short one. You just show a couple of vectors, for example, from the user one buying a lot of products. You say this product is a 1 or this is a 0 because you didn't buy it. And you also show a second set, another vector, for example. So where were you sending that information? Did you write your own neural network? Did you use any library, TensorFlow, or were you using Hadoop to do that validation?
Yeah, that's well. No, I mean the vector transformation was done just like with a script that I did. It was not a very complicated one, because I just store in a map. I just store the product ID and the one, or just the product ID, and all the other products are going to be 0, because otherwise I will end up with a array of 40 million products, so to say. Yeah. And then, well, I have these little maps of products. They were stored in a database in MongoDB. And then from Spark, I can take those data directly from Mongo and do the cosine similarity calculations. I don't know if that.
Okay, yeah. You did the evaluation after storing everything in MongoDB.
Yes.
You took that from there.
Yes.
Using Spark.
Yeah.
Okay, cool.
Spark.
Cool. Thanks, Danilo.
Thank you.
We're gonna do this really fast in Spanish, and then we are going back to English. Vaya por chelas, hay chelas, taperías. Go for beer. Is there? We're gonna set up quickly some video because we have this remote speaker. We are gonna have a special talk with Grid Dynamics. It will be 5 minutes, so you know a little bit more about the company. And then we go back with the online speaker.
Que si quieren una cerveza o un consejo millonario. ¿Qué sigue, güey?
Orden. Y después se pasa a
No voy a tomar algo. Sí, sí. Sí, sí, correcto.
Pero a ver,
que no sé cómo chingados ponerlo, güey. Se para display. Sí, dale.
¿Cuál es el botón? ¿El de home? ¿Pone home? Cambia el source ahí
a ver, güey, comparta el video.
No, pero primero vamos a hacerlo de...
Sí, pero ahorita déjame quitar todo una vez, güey. Y que hable ese güey nomás para un texto. Te voy a sacar, así voy a meter al orden. Ah, no. Entonces,
pero vaya por
Hola, hola, hola. ¿Me escuchan? ¿Me escuchan? Dos.
Pero escuchamos cosas.
Sí, dos, dos, dos. Probando, probando, probando. ¿Sí? ¿Todo bien? Va, genial.
Something also different. We are going to have a remote speaker because, you know, I told you before, he is probably on COVID, so yeah. I asked you, this is weird, but I asked you to be quiet because the sound will be only the TV sound. So hopefully everyone will listen properly or good or have, I don't know. Hopefully everyone will hear. So yes, I introduced to Ray.
Yeah.
Ray is the country head of Grid. Yeah, see, yeah, you can clap. Yeah. So I have to be open on this. This is part of me. I know that now it's Grid Dynamics, but before it was Tacit. Can you tell us a little bit about that?
Yeah, sure. So we arrived as Tacit Knowledge for almost 15 years ago to Guadalajara. We were one of the first companies that called themselves like a Silicon Valley kind of company in Mexico. One of the first ones that offered beers 24/7. Probably still the only one. I know that some others do it now, but we came almost 15 years ago, and we've been part of different acquisitions. This is our third one, apparently final one. And Grid Dynamics acquired us a year ago. So actually it's our first year anniversary as Grid Dynamics in like 4 days or 5 days. And we used to be a very boutique kind of company. We did like e-commerce. Dario is one of our super experts in, where is Dario?
He left.
And we've been collaborating with communities for a very long time already. We actually started what it's now called the, what's it called? The Java user group. We started it as a Java Guadalajara community many years ago, 13 years ago. And now as part of Grid Dynamics, we're no longer a boutique company. We're now growing really fast. We used to be 50 to 60 people for a very long time. And now we are growing at a really good pace. We're 100 and something people already. Plus, we are in the process of relocating a lot of our people from Russia and Ukraine, helping them through this terrible situation they're living in that part of the world. And we have already like 30 people and more coming both from both countries and actually from Poland just because he wanted to come. But yeah, exactly. So the kind of company is different, but the culture, the core of what formed us as tacit knowledge is still the same.
Awesome. Well, for the people that is the first time hearing in this meetup here with Remotos, actually, you will be part from our fierce or very fierce sponsors from Remotos. Thank you so much for that, right? But this was when they were named tacit knowledge, right? Is that correct, right? So the question is, tacit knowledge was like one of the very fierce companies here in Guadalajara that offer different 2014, 2012, for the people that is new in this kind of IT world, let's say, have beers in the office, have a ping pong table into the kitchen was very weird, right? Right now it's like a must for all the companies, but yeah, a must at least. And well, what are the challenges that you faced when you transform or you convert from tacit knowledge to right dynamics?
Yeah, it's definitely challenging. The main challenge is keeping the core values and keeping the culture, because again, we used to be a very small company where everyone feels like family, and keeping that when you're growing at a very good pace is complicated, but not impossible. One of the great things we have is we have a very low attrition. We're very proud of, we're kind of famous, have a reputation for that.
Nice, yeah.
For 9 years, we had 0 attrition, like no one quit for the first 9 years that we were in Mexico. Then we're way below the average, the industry average right now. And we keep our core. We have our core team has been with us for 10, 15, 14 years. A lot of them are still with us, fortunately, and we hope that they're going to be here for a very long time. The challenges is pretty much growing and keeping that, but fortunately, we've been able to do it. We're now hiring also remotely.
Nice.
It's a new reality for everyone.
Yeah,
we know
that's
it.
right.
We started doing it before COVID, and it worked out well. Now after COVID is a must, as you said now.
Mm-hmm.
But we're even with that situation, we're still very proud of the family that we still have. It's now a way bigger family, and we're trying to get to 1,000 people, but not in like a year. Like it'll take us, I don't know, 5 years, probably 7 years. Like we don't know, but we want to grow while keeping these values, keeping this core forever. So yeah, it's challenging, but it's doable, and we're doing a great job, I think.
That's awesome. And well, the other question, probably, I don't know if we will do another session in the next inter.
I don't think so. I think
we can do it all.
Okay, that sounds good. So, well, the other question is regarding like the same related with the culture. What is the difference between the culture, right dynamics, and right now? No, tacit knowledge and right now right dynamics. It's the same.
Yeah, we can see other companies that changed.
Yeah, of course. And that's why it's the most difficult part. The main difference, I would say, or more like what I would focus more is on the similarities. One of the great things about being acquired by Grid Dynamics is there's a lot of emphasis with them also in the people they hire. We hire really, really strong developers, really strong QAs, really strong DevOps. We have now way more opportunities that we didn't used to have, like big data, for example. We didn't used to have big data or data science, or many other roles that we didn't have because we did mostly only e-commerce. Now we do every kind of project, and it's way different. The opportunities have grown a lot. So the culture. One of the great things is that the culture was very similar, and that's why we now feel like we finally were part of an acquisition that we feel at home. The companies are very similar. We feel like it's the same. We can say. But at the same time, some companies have gone through that and
Yeah.
they mess up, and we
Yeah,
we
I know
learn
the
a
names
lot.
that they are thinking right now.
yeah, we won't say the names here, of course.
After the meetup, you can go get a beer and I will come to it.
Yeah.
3 more beers and we start showing.
We won't say it on the streaming, but
Yeah, but we're focusing extremely hard in this not changing, especially
Yeah.
in Mexico. We're keeping the same culture. You can see, yes, of course, the pool table there, the food table, but as you said, everyone has now an Xbox, and so even some companies give beer. It's not about that. It's about the people. It's about the team that you have and how they work together and how they talk to each other every day. We haven't forced anyone to come to the office. If you've been to the office today, we're 60 people easily. And just because they want to come and spend a good time with the team, they can work from their homes, but they come to the office and have a great time with the team. We are also now doing internships. For a long time, we didn't do internships.
Nice.
We didn't hire juniors. Now we're hiring juniors. We're training people, and we're doing a great job. We have today 6 people join, and they're amazing young people, 20 years old, 22 years old, with great potential, and I'm so proud that we're going to be helping them grow to where they want to be.
Okay, and I think that question that probably is also related that when something that you just said, the pandemic started, there were a lot of changes for different companies. There were layoffs, and then comes this boom of hiring people. All the companies needs developers. All the companies is fighting by the developers. What are the difference or the differentiator that Right Dynamics has compared with the other companies, and how Right Dynamics or what Right Dynamics will offer to the community?
Sure. So there's many things. We like to give back to the community all the time. As I said, we started the community, the Java community, to talk to the people, and many years ago, again, 10, 12 years ago. But also the internships is a big part of it. Like, we are trying to train people, help people. I already mentioned we are relocating people that are going through very difficult times of war, and we were fortunate to be able to get some people out of the Ukraine in time, and we relocated them to different parts. Also from Russia, a lot of people don't want to be in Russia anymore because they disagree with their government and the decisions they're making. We're actually closing the operations in Russia. There's no longer a Grid Dynamics Russia, and it's part of this because we don't support the war. So all of that people, everyone, and we had 600 employees in Russia. They were all offered the opportunity to come to different countries. We have offices in Serbia, Moldova, many different countries, Poland, Ukraine, of course. And we were able to relocate many of them to Guadalajara, and they're doing a great job, and they're helping us training our employees, not only the employees, more like the interns. So it's about giving back. We have always done a lot of giving back to the community, and we're trying to do the same from now and forever.
Nice. That's awesome.
Oh, one more thing. Not only do we pay great salaries and have great benefits. Joking aside, precisely because of this, there's many companies coming.
Yeah.
One of them could be us, because we're as Grid Dynamics, we're kind of new to the market.
Yeah.
But we know the market, we know the people. So using this opportunity, we were able to now offer great salaries, increase our benefits. If you have any questions about benefits, etc., our talent acquisition team is here somewhere around.
There's Lilian.
There's more people. There's other people that Jorge and Tejera, they will be coming later, and they can fill you in with all the information. But in general, it is a great company. We are formed of great people. We're gonna continue focusing on that. So if you're not great people, of course, everyone has an opportunity of joining us. We used to be extremely strict. We're still very strict. We're not just as strict as we used to be when we just wanted to be 50 to 60 people. Now we want to grow to 300 by the end of the year, probably 250. So I wouldn't say that the bar is lower. I would just say that there are more opportunities to come in, grow. We have our new slogan, "Prepare to Grow," and it means something. It really is about growing and becoming a great engineer, architect, whatever you want to be, manager, anything you want to be, there are opportunities.
Awesome. Thank you so much, Ryan. Thank you so much again.
Thank you.
Anything else?
No,
Okay.
that's it.
Cool. Brian will be around, so
Yeah,
if you
we'll
have
be
questions
here.
or sometime, take a beer
Yeah.
and talk with him. So our next speaker is this guy that is from Zamora. He's not far away, but
Por una razón dejé de escucharlos. ¿Me escuchan? No tengo feedback. Super. Ok. Um, no tengo feedback, entonces no sé si ya es mi green light. ¿Sí? Ok, genial. Gracias a Babo de Cartel de Santa por la presentación. Okay, so now I'm going to switch to English. Thank you very much for the invitation. It's a great honor and I'm such happy being here again in this community. I feel a lot of, I mean, the community, they're all my friends, and I know they're doing great job to keep the community up and running. So it's super fun to be here again. Today I'm going to talk about Terraform, which is it's a cool tool that we have now on. This is the first time I'm working with Terraform, so I'm still learning. There's a lot of things under the hood, and the main, like the name of the presentation is getting the CI/CD a little bit more handsome, more than which is right now. So, who am I? I'm a software engineer. I do software engineering for SoftServe. I joined recently in March, just brand new. Still have the feeling with as I said, guys, at Great Dynamics, we're still checking out and fighting against everything that's happening in Europe. SoftServe being a Ukrainian company, so we're dealing with all the stuff. We're also working in relocations, and the things are going to get really great for us here in terms of technology and what we're doing with this stuff. First, I want to start with some brief regarding the things I've done so far to get to Terraform, or why I'm getting to this point to Terraform. I started my career as a front-end developer. I was, doing CSS, HTML, ugly pages with CSS, until I started to go deep into more technologies, and I realized that there's something called backend. So I became myself into a full stack developer, which was a really bit more exciting, just doing web pages or UX development. So when I started to do backend and front end and doing some of the things with databases, I started to think like, what's happening beyond that? I mean, I do my functions, I create my controllers, I do my styles, and that's it. But who's taking these styles, who's taking this functionality into the next level, right? To the next environment, who's testing it, and what's happening when I commit the code and when I push to the branch. So I realized that there's like an alien race there called DevOps. DevOps guys, I really love these guys because they make all the things possible, right? They're in charge of getting all the infrastructure up and running. They prepared your platform. They do the webhooks. They replicate among like environments, and they do a lot of crazy things there. And I was totally amazed of how savvy they are. So I started to check out this. I went to a company that they were super focused on formal education on cloud technologies. And I got my first certification with AWS, and my mind just blew, right? Working with these platforms and working with these technologies is super cool. And then I got into this point, which is Terraform. And Terraform as a concept is really I don't know, it has some meaning for me because it's like all science fiction, right? Like it's like terraforming a planet, terraforming something that it's really cool. And I don't know if this is like an open question. I can hear you guys, but maybe you can put in the comments if you've seen this movie, Titan AE. This is a dystopic future where the human race is in a war with some aliens race called the Dregs. So there's one point where the conflict is so hard that the aliens destroy the planet, but the human race has been working in the Titan project, which is like a spaceship which has inside a set of ADN and like all the base for the life. So this project of this spaceship, what it does, it uses energy and it uses all the parameters that it has inside to terraform a planet and to give to the human race an environment which is stable and predictable, or actually a planet that has everything that we know, right? To be like a hope for the human race after the destruction of the planet. And this is something that it's super related to Terraform, to the actual tool that we're going to see today, because it uses like kind of the same concepts of how the Project Titan in the movie was developed as. So he's just like a quick give, or how the planet is being destroyed, and then the entire concept of terraforming a planet and an environment. So this is where Terraform from HashiCorp comes into the game. Terraform, we're going to see a little bit of concepts, theoretical concepts. Okay, there you go. Sorry, I just missed the image for a brief second. So yeah, Terraform comes into the game to actually all of us to terraform an environment, or to create an environment for our systems and applications to be the hope for our human race. Sorry, I made the presentation in Spanish, but I will translate it in English. The definition of terraform, or what's the main proposal from HashiCorp, which is the creator of this tool. It's an IaaC platform, right? It's a software tool that it's an infrastructure as a code. When we're talking on this area of or these tools, we have a lot of options, right? But we're just going to focus in Terraform. As I mentioned, this was created by HashiCorp, which is an American company based in San Francisco, and it's being used for cloud and public cloud infrastructure. It has their like the open source, like the tool is open source, but we have different flavors for enterprise and cloud managed Terraform tools. What is this for? It's to manage infrastructure by using a high-level language called HCL, which is not the company that is in the Minerva. It's not that company. It's a language. It's called HashiCorp Configuration Language, which is really similar to JSON. Actually, Terraform allows you to use JSON as well. So you have these two options. When we have this concept, the infrastructure as a code, it takes three inputs, basically. Templates, which is the structure of the platform or the infrastructure that we're going to use. The scripts, which is the actual configuration, the code. And policies, which is more applied for security, right? So Terraform takes these three inputs and allows us to have infrastructure for networking, storage, cloud infrastructure, or even for application security, databases, containers, virtual machines, etc., etc. So there's a lot of things that we can do with Terraform using these three inputs. Basically, it's provisioning infrastructure using software for consistent and predictable environments. And this is where the Project Titan from the movie, it's related to Terraform, because as I mentioned, the spaceship had inside an ADN container of all plants and animals from the Earth. And so it's consistent because it's something that we already know. I mean, these ADN containers were from animals and plants that we already know. And we already know that this will be the output, right? So it's consistent with what we have right now, and and we know from firsthand that what we're going to have, right? So this is like kind of the similarity, and this is how I like put these things together into my mind. How does Terraform works? Basically, it has a set of tools, but it's classified in two big components. The core, which is the actual binary that it's working with all the stuff, which includes two inputs: the Terraform config, or the TF config, which is the actual code that we're going to define, and the Terraform state, which is what's the reference for the infrastructure that we're going to use. In the moment, we will see what's the state and how Terraform handles this. And then the second part, or the second component, is a set of providers. If you go into the documentation, you'll see that we have two words that they probably can be confused as the same: providers and provisioners, but they are not actually the same. The providers are part of this second component, which allows us to connect with different platforms. They're like small CLIs embedded, like packaged for Terraform to use AWS, Google Cloud Platform, Azure, Kubernetes, IBM, Red Hat, etc. And they have over 100 of providers. And provisioners, they're packages or tools that allows you to install more tools inside a server, for example. Like I can use a provider to get an EC2 instance in AWS, and I can use a provisioner to install Node.js, Apache, or Nginx server inside this EC2. So that's the difference between the providers and the provisioners. Overall, this is kind of how Terraform works. It gets the up-to-date state, the latest up-to-date state, which is the reference of the infrastructure that I have. It gets the configuration, it reviews the configuration, the code that we're providing it, and it compares the next state, like the next state that Terraform is going to generate with the actual state. And it defines if Terraform needs to create, update, or destroy any resources or anything inside the infrastructure. Then after comparing these states, it creates a plan. And this is one of the biggest features of Terraform, the plan. We're going to see it in a brief. But the plan is a set of steps or jobs that Terraform needs to perform in order to get the infrastructure up and running. Then it applies or executes the plan using these providers that I already mentioned, and then it saves us the state inside the configuration, and it sets us up the latest up-to-date state, right? So this is basically the process that Terraform follows. This is an example of a single provider. As you can see here in the first block of code, I am using AWS as a provider. And I can define a version. Version is actually not required, but which is actually required is the region. This is not related to Terraform, but there's a lot of resources or services inside platforms of the cloud that they're not available in all regions. I remember I worked once with a project in China. So we were using AWS, but we were using the region in Shanghai. So this region didn't have a lot of services that we had, for example, in US East 1, which is Virginia, North Virginia, right? There's a lot of things that they're missing. So this provider it will be such different from Europe to US or Asia providers. Because it needs to define what will be the things that you will have available for your provider in your region. And then the second block of code, we can see I'm creating a VPC. This is an example. I'm the only argument that needs, it's like this CIDR block, which is the subnet I want to implement on this one, right? As I mentioned in the very beginning, there are a lot of tools that allows us to do the things that we're going to do in Terraform. But Terraform, or one of the biggest or the coolest features is the HCL language, which is declarative instead of imperative, such as Ansible or Puppet or Chef or other tools, right? The main difference between these two languages is when you use imperative language, you specify to the tool what the tool should do, right? And if you use declarative language, you just said, okay, I'm expecting this, and you have to deal with it, and you have to, you can do whatever you want in order to receive this output. And I have a little example here. Let's say that we have an infrastructure with 5 servers with X configuration of network, and then we have an AWS user with group A of permissions. If I'm using an imperative tool, I will need to do a modification in this way. I will need to specify that I need 2 more servers, so add 2 more servers, add a firewall, and then add more permissions to the user. Taking an example, right? If I need this is specified. But in the declarative language, which is the HCL, and this is one of the features from Terraform, I just said I need 7 servers, I need a firewall, and I need a user with this B set permissions. So I don't need to say to Terraform, hey, you need to do this. You just said I am expecting this, and you can do whatever you want for the output. To end a little bit with the theoretical part, we have a lot of comments, but these are the most used comments, or at least the comments that I'm using the most day on a day. The first one is refresh, which it queries the providers to actually get the state of the infrastructure. It's like the git fetch. When you have new branches in the origin, you use git fetch in order to retrieve information. That is kind of the same concept. Like you refresh what you have in the platform. Then you have a plan, which is creating the execution plan. It's creating these steps and these jobs that I already mentioned, and the order on how it will be working. Then we have the apply, which executes the plan or applies the plan that we just created. And this is like a heads up. Apply, the command apply in the background, execute is refresh, and plan first. Then if you want if you know that your plan is already in a good shape, you can just go with apply and you will get it in the infrastructure. I don't recommend it because I always do the 2 steps in the separate way, because when you do plan, you can troubleshoot things that you'll probably have in your code, right? If you're missing a variable, if you have a typo, if you're missing a definition, if you are using not the proper provider or not the proper resource definition, you will get it here. If you use apply, it will get to plan and it will just break out and say, I can apply anything, something that is wrong, right? So creating first a plan and then checking the logs and reviewing the plan, it will be always best idea. And then we have finally destroy, which, guess what? Destroys all the resources and in the infrastructure, right? I don't know if I can just make a little pause here for questions for the technical part before we get to the live demo. I don't know if there's a chance. If not, I can just continue.
Yeah. Hey,
Can you
hear us?
Yes, I can hear you.
Awesome. Cool. Okay. Let me just put you in the big screen like that. That's what Fer wanted.
Yeah.
You don't move anything else? Questions? No? No? Okay. People doesn't have questions. They say that you explained perfectly.
You're awesome.
You're awesome.
You're handsome. No, awesome. No, handsome.
Someone asked if you have a Twitch channel or an OnlyFans account where they can find you to do these kind of things.
I need to open my OnlyFans, my plan OnlyFans.
Okay. Okay, you can proceed with your demo, and we will see after.
Okay. There's a 15% off if you present this coupon here. It's called j4G Terraform. You'll get 15% off on the OnlyFans. Okay, so
Asun? It's very short. Asun, come on, plus. We don't see your screen perfectly. You have a very small and tiny.
Now, oh my God, I think that's good enough, right? Cool. So yeah, I'll proceed with the demo right now. The demo is in two parts. I have like a base explanation of how Terraform works. And then there's a second part when I have a complete repo to actually demonstrate a CI/CD pipeline working, right? I will share this repo with you guys. You can just sit down, check it out. And if you have some questions regarding the code, we can connect just after this and I can guide you and you can start working on the as a developers or as a maintainers for this great demo that we're going to see. So first things first, I'm going to explain a little bit how the structure of the files are in the in the folder. I just have a main.tf, which represents the Terraform code. I'm using HCL right now. You'll see it's super similar to JSON. It's just like you have a brief differences. So this is the demo. Oh, sorry. This is the demo I prepared for today. We are going to select a provider and we're going to create a resource, which will be an EC2. So I'll have here, wait a second. I have here my AWS console. I'll go to the EC2. First of all, I need to explain something. You need to install Terraform. If you go to terraform.io, the first step you need to download the binary. You have to have it in your bash, right? You can use, as I mentioned, it's open source. You can download the binary. You can use it in Linux, MacBook, in Windows, whatever you want, right? So after you install the Terraform tools in your local, I use Homebrew for this. You need to create, or it depends on the platform you're going to work, but I'm using AWS right now. This is a brand new account that I created for this. First things first, I need to create an AWS secret key and an access key, right? So I already created this before the demo. So this is really important. The provider for Terraform for the AWS needs the access key and the secret key. So basically what we're going to do is we're going to define a resource in the Terraform so we can see it here. It's super simple. I just need the provider, which is AWS. And I have Copilot here in my VS Code, so I will just follow this so it'll be quicker. I'm defining this to be in the region to be US East 1, which is North Virginia, as you can see it here. Okay, so I need the access key and the secret key here. I will just delete this after, so it doesn't matter if it's here.
Hey, Danny. It
Yes.
looks awesome. It looks great. Everyone is clapping, but we cannot see it. So can you press Command, comma, and increase the font size instead of the whole Zoom? Yeah, that thing. Can you put the preferences and yeah, a little bit more? Just a little bit.
More?
Is it okay? Okay, is it better now? Thanks a lot.
We love you.
Okay, okay. I love you too, guys. Okay. So I just set here the access key and the secret key. They're my actual keys, so don't copy them. I will just remove the keys after this, so it's fine. So these will all need to connect with the provider and with the AWS platform. So the next step I will create a resource which will be an AWS instance, regular EC2. So I will define which will be named as demo1. Oh. And I will, I have here in my site monitor the configuration. I will explain it to you. I will use a specific AMI because I want to be charged and I don't want this to be expensive. So I'm using a super simple EC2 instance. We can review this. This is more DevOps stuff, but this is an AMI that contains a small Linux. We are using a T2.micro. That's the instance type. And we have some tags for this specific EC2. So if you see here, I don't have anything. I don't have any instance running. Everything is like clear. So next step, what I will do is I will increase this guy more. So I will run the first command in the that you need to run in a project, which is Terraform init. Terraform init will connect all the providers and will get all the core and all the things, the dots together for you. So this is the initialization of Terraform. It's good. It's green, so we're allowed to proceed. Next thing I will do, I will run the Terraform plan command, right? So I don't have any changes. So far, I am actually running something in the actual state. So I don't have any changes. My Terraform is telling me everything is okay. If I remove what I have here in the state for Terraform, probably I will get a better log of the clear plan. But right now, I will just go to Terraform, apply. So wait a second. Let me remove this. I will change the name just to be sure that we're good. So I changed a couple of names of namespaces that I had for the first demo that I created for the talk purposes. So I'm just rerunning everything with different namings. Right now, I'll do the Terraform plan again. And we just wait a couple of seconds. So here we have this log. This is the important thing that I mentioned. I always run plan first in order to see what I'm doing, right? I don't want this to be charged or become something different there. So I am creating a resource called demo2, which is an AWS instance. I'm using this AMI and a lot of things. As I'm using a declarative language, I'm just telling, I need an AMI, sorry, I need an EC2. I don't mind anything else. I just need this EC2 and you need to figure out how to do it, right? So there was a lot of information for the EC2 here that we don't care about it right now. Maybe in the project we do, But this is just for the demo purposes. We review this and we say, okay, everything's fine. So I will do Terraform apply. Oh, before this, I will just refresh here and tell you, okay, this is basically clear again. And I will just apply this guy again. Okay, it shows you the output for what you're creating in the infrastructure, and then you need to confirm this. I'll hit yes, and Terraform will automatically start doing all this stuff. It's creating the instance. Still creating, 10 seconds. This resource, it's one of the resources that takes more to create because it's an EC2, it's an instance, it's something that is infrastructure as a service. So I'm just rerunning here, just a couple of seconds more. It takes like 40 seconds actually. There you go. So I will just sum in again. There you go. As an art of magic, we have an instance called demo2 with the ID that I need. I mean, I have a bunch of information out here, but it's not relevant for the plan or for the application of this plan. Guys, how we're doing with time? I have another like demo.
No problem.
We're good. Okay, cool. So this is an explanation, a demonstration of how Terraform will create infrastructure for you. So this is one of the cool features about how you can, with code, create a lot of resources in the platform that you need. Right now, I'm working. What was that? Okay.
Nothing. Go ahead.
Okay.
We love you.
Right. Okay. So the next thing I'm going to do, I'm going to show another branch from the repo that I have, which has more files, and I will explain just real quick what they're doing. Okay, so changing a little bit the code, I still have a main file, which is the input is like the index in HTML, the index.js in JavaScript, and the main in Python and this stuff. You know, you got the concept, right? So this main will actually put all the things together from the TF code that I have in my repo. It will take all the variables from here, from the variables.tf, which I'm defining the region, I'm defining the profile, I'm defining some shared credentials file, I'm defining like all the variables that I need. And I also have a lambda.tf, which defines, this is the profile generator lambda, which is a module that I'm creating for a lambda. So I will create a lambda function, and then there will be a pipeline which will act as a CI/CD pipeline, and it will take this lambda to the very end state of AWS. So what I will do, I will show you another way to do it. I was doing the first demo, I was doing it on my local, but this is Terraform Cloud, which is the most enterprise or the most pro way to do it, because you have the cloud managed stuff. So this is my workspace. When you open a new account, you can do a new workspace, and then you can create organizations, and you can invite your team. You can do a lot of cool things. but this is my first workspace, and this is the workspace I will use for the demo. So if I open the Terraform Lambda workspace, you'll see here a lot of things. They're not relevant right now. I'll just show you what I will do with the pipeline and with the CI/CD. So what I will do, I will actually commit the code that I have here. So it has like a webhook that it will gets the code when it detects that it's pushed to master. I will be able to see all the magic of Terraform. So I have it here in a separate I'll just do a quick commit. It will be j4G demo commit, and I will push. If I go here, well, actually, I will be 5. One second, let me show you the, This is my repo. So what I did was I just committed 1 minute ago, I committed a change here. So Terraform will detect these changes. It will create a webhook in order to execute the pipeline. And I will go here to version control. I will just define which is the repository. I stopped here because I wanted to show you how I connect and how I will create the webhook. I select my repo, which is this guy here, and then I accept everything and I update. Right. So if I go here to overview, I will start a new run. Demo 2 plan and apply, and I will start running. So this the same thing I did in my local environment. It's been executed here in the Terraform cloud. So what we're seeing here, based on the repo, when I push something into the repo, I will select this commit, and then here I will see the plan results. So the plan is telling me I will create this this function, I will create this IAM policy, I will create this external archive, I will create this couple of things here. There, it's using an S3 bucket in order to store the configuration and the state. So I have all my plan here. Everything is going smoothly. If I have some errors, I will see them here. I can show you what's the output for an error. So you will have, it's like a log, a normal log that we have, but now using a web UI client. So I go here to the plan that I have. I go here and I search for Lambda. There's no Lambdas here. So if I go back and confirm apply, okay, love j4G, I confirm the plan, and the plan is being executed. Now Terraform is applying all this stuff. So we will just wait a couple of seconds for this to be executed and completed. We're applying this guy. Okay. And we finished our tasks. Now, if I go to Lambda the Lambda function, yay, we have here this profile generator Lambda, which was the Lambda I created. If I go to the source, I will go to the source first here, index.js. You'll see that we have a Lambda with it just had a simple handler, and it returns it's like a REST Lambda, and we got a body like, hello, I'm a Lambda created from Terraform, saquen las chelas, right? And if we can see, we have the Lambda here. Hi, I'm a Lambda created from Terraform, saquen las chelas. So in conclusion, awesome. what I did, I just committed and pushed to a certain branch. Terraform Cloud detected the changes and runs everything, the plan and the application for this plan. And there you go. That's Terraform in a nutshell.
Nice. Thank you so much, Danny. Can you hear us? Yeah. The only question we hear is how much this demo cost you? Because we know that it's in Amazon, so $200, $500 just for the demo.
Actually, I'm in the free tier, so we're good.
You think that? You will check your pay bank account.
Yeah. That's what the OnlyFans is for. Yes.
Danny, thanks a lot. We are gonna have to skip the question part because we are already over sometimes. So thanks a lot. Everyone in here is very scared about Amazon. So thanks for showing us that it's actually really scary. So thanks.
No, it's very good. Great demo.
Cool. Thanks, Danny.
Thank you, guys. Thank you. Kisses.
Besitos. Chido. No te deja ver, pongo acá la cámara.
We're gonna do one thing that we usually do at the end, which is So we're gonna have a break of 10-15 minutes so you can grab some tacos. Spanish. And he's also very vulgar. Yeah, sorry, but he su gracia. No se puede traducir eso. Yeah, his personality is only fun in Spanish.
And so.
So yeah, we got 10-15 minutes, so you can grab tacos. You can bring it to your site or whatever, and we will be back with Joel. Diplomado de base de datos que da un profesor de debate. Yo no era asistente y estaba como no, güey, esa es una michelada, güey. Una pelita de pollo y ¿verdad? Tú te la instalaste para la basta, güey. Perdóname, porque te metido, güey. Javi, podríamos dar. Estamos así, como sí, acá, y dice el profe, no, pues lo desplegamos. Vamos a ver si se empieza a replicar. Y de verdad, se escucha sin un silencio total. Pero así, güey, así. Random, güey, con esa cuchara. O sea, puedes, pero nadie lo hace, güey. Sí, mira. Los ampliateros, hay huevos, güey. Eso no puede llegar a la ley.
Es que lo tienes cabello, hay hecho las cosas adentro.
Gracias.
Adentro del canal.
Sé que somos centristas, güey.
Aunque ni siquiera lo hayas probado, ¿qué chévere sal? Sal y pongo.
Lo que no hayas probado. Sal no, güey. Que no te la compro. O sea, la sal no se la
Perro planeta bien.
Algunos abogados,
las extensiones. Estoy de acuerdo que es móvil, pero hay diferentes cosas. Por ejemplo, esta
Hay un centro de software, güey. Ay, que le falta fracción. Igual no se entiende.
Ya pasó, güey, pero después de 12, sí. Sí, como ya
Esto. Animalito. Chiquito.
Después nomás va al baño y ya se jala, güey. Ahí ven. Apple TV.
Vamos a ir empezando a señalar a Joel. T-5. 5 minutos.
No, pues aquí, güey, es un cajón, mira. Me cabe, güey.
3 minutos o menos, como 5.
Atención uno, güey.
Es válido.
Aparte ando medio cansado, güey. Atención, güey. ¿Qué? Apple TV. Atención. ¿Cómo? ¿No te saltaron Apple TV? Ah, no. Kitchen 1. Ahí va. 9, 6, 5. Así lo voy a comprar. Aparte, güey. Pasa, ¿quieres dos plays? Nomás por compartir ahí. ¿No gustas hacer como que algo locochón? Así aparte, pues voy a correr nada más un action. Pero no estás en la misma web, ¿no? ¿En la misma pantalla o dos plays? No, dos plays. Porque si estaba apenas viendo cómo trabaja el pinche Big Sur, güey. ¿No hay Big Sur todavía? ¿Cuál es el otro? No, Monterrey. ¿Qué quieren hacer? Monterrey, güey. De una R. Monterrey. ¿Qué quieren hacer? ¿No está? ¿Ya? Ya. Y ahorita, pues ya, güey. Screenshots y me. Pero dale compartir pantalla, güey. No, compartir. Dale compartir, güey. No puedes compartir, güey. Ah, chingada, güey.
2 minutitos, gente hermosa. Vayan sentándose, ocupando lugar, llevando sus tacos, porque va a ser los a saludar.
Voy a salirme tantito, güey. No, porque me pide esta madre que. Ah, que revises para compartir. Otro que necesita revisar para compartir. Yo me quedo a veces, güey. Aquí lo voy para allá. Cámara. ¿Cuál comparto? ¿La 1 o la 2? La vas a presentar, güey. ¿Eh? Donde vayas a presentar, pues. Ah, es la 2.
Gente, creo que esta parte va a ser interesante. No sé si hay que presentarlo. ¿Quién es la primera vez que vino ayer por Guanatos?
Yo.
No sean mamones.
Sí, güey. Ok. No estoy 100% seguro en esta ocasión de si tenemos cumbias, tenemos... Sí, sí hay. Para mí es un honor, es un orgullo que una vez más tenemos de este lado a el buen... No, ahí está el buen Joel. Es un orgullo tener una vez más a Joel, uno de nuestros aboqueros, una de las personas más técnicas que tenemos en la comunidad, que de verdad siempre que viene nos presenta algo hermoso, apantallador y gracioso a final de cuentas. Entonces,
Ahora es la peligrosa.
Ojalá el maestro de Machine Learning me hubiera contestado porque era peligroso para todo el mundo estaba aprendiendo. Esas son las preguntas que siempre me he hecho. Ok, bueno, esta es una plática. Ya me he hecho de hueva de todo.
mira, mientras lo que se duerman sean ellos y no tú.
Sí, es cierto, ¿verdad? Si me caigo acá en medio. Okay. Bueno, el día de hoy, miren, para quitarnos un poco el desempanse, ¿podrían pararse todos, por favor?
Amén, amén.
Ahora quiero que se visualicen, cierren los ojos y se visualicen como gente ganadora. No se rían, ustedes son ganadores. Están aquí, no están viendo el partido del Atlas. Digo, no. Sí, igual lo voy a ver en repetición, no, igual en mi tele ganan. Entonces, nada, siéntense, güey, ya no me son ganadores. Entonces, bueno, ya me presentó Ciel, pero me gusta presentarme a mí porque obviamente me gusta el anime, pero sí me baño. Entonces, ok, ahí está mi nombre, yo soy frontend developer en Platzi. Si tienen alguna queja de la plataforma no es conmigo, pero, bueno, sí. Soy full stack developer, soy GDE en Web Technologies y Google Maps Platform, maestro Pokémon, soy developer de j4G. Y me gusta comprar cosas innecesarias, ¿no? Entonces, si ustedes se identifican conmigo, con esa inteligencia artificial de Amazon, y dicen, güey, deberías comprar esto. Y yo güey, ya lo compré, dame tantita chance que llegue la quincena. Son de los míos. Y pues están mis correos y mis contactos. Igual no voy a contestar, pero pues... Entonces, un pequeño disclaimer, nada más porque no quiero que me despidan en ningún lado. Es como de que las expresiones y opiniones solo me pertenecen a mí. No represento una compañía ni a sus intereses, aunque cada vez que usan Lighthouse es como me dan $1, entonces usen esa madre. Taco Bell no son tacos de verdad, se los juro, porque a veces te encuentras en otro lado, y cuando un mexicano dice que pica, que no pica, en realidad sí pica. Entonces, esta pregunta la hago solamente en Meetups Presenciales, ¿ok? Cuando son online no la hago porque está difícil tener retroalimentación. Y aparte es como de que, no sé, yo no soy tan guapo como Lani como para verlo ahí, de que estar atento a la pantalla, que ese güey es hermoso, ¿verdad? Entonces, esta pregunta es crucial y contéstela con ganas como si ya hubieran comido desde hace rato y no tuvieran mal del puerco, ¿no? Entonces, ¿quieren memes? Sí, sí quiero, entonces... Bueno, voy a hablarles un poco de esta parte de frontend. Se los juro que somos gente que no solamente sabe HTML, CSS, a veces también manejamos un poco de JavaScript. Y en algún momento tenemos que hacer que esas cosas, pues, ¿cómo decirlo para que no suene feo? Que la gente las pueda consumir, ¿no? Porque la gente del backend dice, no, es que el backend es lo más importante. A ver, dale tu API al usuario culero a ver si la puede ver. Entonces, como de que... Ajá, que aprenda. Entonces, pues, todo comienza con esta parte de distribución de software, ¿no? Sorry por hacer el inglés, pero la verdad es como de que te van como el de puerco, entonces traducir está medio feo. Todo comienza con ese deployment, ese maldito deployment. A ver, ¿quién de aquí hace, bueno, no sé, ha liberado alguna vez algo a producción? ¿Quién de aquí tiene alguna idea de cuál es el proceso para que llegue a eso a producción? Ok, hay varios. ¿Quién de aquí quiere un consejo millonario o quiere que siga con la presentación? Yo quiero que siga. ¿Consejo millonario? Ah, pues se la pelaron. Si tuviera esos consejos no estaría aquí, güey. Entonces, ¿quién de ustedes ha construido software que no necesariamente consuma una aplicación? Bibliotecas, por ejemplo. Ah, tú no cuentas, güey. Tú estás en otro lugar. Entonces, Una de las cosas, por ejemplo, es esta parte de, oye, ¿cuál es el proceso que hay para, por ejemplo, liberar una librería de Node y que se pueda pues, distribuir, ¿no? Y es como, pues no sé, güey, haces código, lo subes al repo y Harry Potter viene, güey, te dice, a huevo, lo voy a llevar, ¿no? Entonces tenemos herramientas como Travis, o herramientas como Travis, o Circle CI, o cosas que son gratis porque nos duele el codo pagar herramientas.
¿Travis es un ejemplo de eso? ¿Travis es un ejemplo de eso?
Sí, también.
¿Travis es uno de esos ejemplos? ¿O?
¿También? Entonces, y Travis también. Entonces, sí, creo que también Travis. Entonces, no sé si lo había mencionado Travis. Ok, bueno, ya basta de ese chiste luego. Entonces, pues está esta parte de GitHub Action, ¿no? Que tampoco está viejito, tampoco está nuevo, es como de que está chido. Y pues básicamente es, normalmente los repositorios, cuando subimos código, hay como, imagínense como, no sé, como la señora chismosa seguramente vive en al lado de su departamento, que sabe de todo, o sea, antes de que ustedes se enteren así como de, hermano, ¿viste lo que pasó en cierta empresa? No. Entonces, dice, güey, algo pasa, ¿no? O sea, ya teníamos hooks en GitHub que hacían este tipo de cosas, ¿no? Entonces, pues llegó GitHub Action y dice, ¿sabes qué? Yo también quiero ese dinero, ¿no? Y pues empezaron a meter esta parte de GitHub Action. ¿Y qué es GitHub Action? Bueno, simplemente es un servicio que cuando tú subes algo, como esa señora chismosa, va a decir, tengo que hacer algo. Probablemente ella se lo va a contar a sus otras amigas, pero o también soy yo chismoso para no incurrir en algo, ¿no? Entonces, pues, está atento a ciertos eventos como, por ejemplo, pull request, cuando haces un push, cuando pones un issue, o cuando tu crush se enamora de ti. Eso último no estoy seguro, pero si lo tuviera, pagaría un chingo de eso. ¿Cómo es que funciona GitHub Action? Bueno, lo que va a pasar es que va a haber un evento, como j4G. Me pongo la camiseta del evento para que vean. Ojalá me pusiera también la del trabajo. Entonces dice, algo pasó, güey. Y va a decir, sí, ¿qué tengo que hacer? Güey, pues tengo que correr un job. Ahora, esto normalmente que esta parte correspondería a estos runners. Por ejemplo, todo esto, cuando ocurre un evento, se desata algo muy interesante que se llaman workflows. Los workflows, voy a ponerlo como algo muy, ¿cómo decirlo? Algo muy simple es, bueno, cuando un workflow corre, tiene ciertos jobs, y estos jobs tienen ciertos steps para poder llegar al resultado, ¿ok? En un workflow podemos tener varios jobs, como la gente que dobletea en sus trabajos, entonces, Entonces, pues, ¿qué son los workflows, no? Simplemente son archivos de configuración porque nos cagan los JSON. Es como, en menos 3 está chido ese chiste, pero ahorita no. Entonces, tenemos un YAML que dice, ¿sabes qué, güey? Tienes que ponerlo aquí. Yo no tengo pedos con eso, es como de que digo, bueno, está bien, tío GitHub, te voy a hacer caso, ¿no? Y pues vamos a escribir los jobs que necesitamos ejecutar cuando algo pase, como esa señora chismosa. Bueno, le voy a decir señora chismosa. Entonces, como ese señora chismosa, cuando pasa algo, tiene que ser algo, tiene que reaccionar. No lo puede evitar, es parte de su ADN. Como ahorita que todos le echaron un chingo de salsa a sus tacos queriendo ver. Entonces es como de... Estamos en Guadalajara, güey. Sí, lo sé. Sorry, yo vivo debajo del agua, no puedo decir nada. Puerto Veracruz. Entonces, ¿qué es lo que tiene el workflow? Ahí arriba, por aquí, porque la letra no se ve, tiene un nombre, porque el nombre tiene poder, así de que dice, ¿sabes qué hago? Tienes que saber qué estás haciendo, ¿qué es esto? Ok. Por ejemplo, este es un ejemplo de, está levantando la mano, qué chido, güey, ¿qué quieren preguntar? De eso. Sí sé que para otra cosa, pero no, está chido. Entonces dices, oye, ¿sabes qué? Este va a ser el nombre de tu workflow. Ahora, ¿cuándo va a suceder ese workflow? Porque los workflows se generan a través de eventos que pasan. Entonces, el evento al que yo estoy diciendo, ¿sabes qué? Cuando se haga un pull request. Ok, pero tenemos que tomar ciertas consideraciones, ¿no? Por ejemplo, si es un proyecto de un solo repositorio, no hay tanto problema, pero en este caso yo tengo un proyecto en un monorepo, entonces es como, tengo que solamente ser consciente cuando pasen los eventos en ciertos paths o ciertas ubicaciones del directorio, ¿no? Bueno, del repositorio. Entonces, dices, oye, ok, voy a responder a estos eventos, ¿en qué branches? Porque normalmente como desarrolladores trabajamos en branches. Si no lo hacen, pues no sé en dónde están trabajando, güey, así de sálganse de ahí, güey. Y aquí tenemos nuestros jobs. Entonces, puedes definir uno o varios jobs, no importa. Se puede ejecutar en paralelo, se puede ejecutar de manera serial. Inclusive, ustedes pueden poner como otros jobs como dependencias de otros jobs. Así le echan la culpa al otro güey de que, pues sí, yo iba a terminar mi ticket, güey, pero pues es que este vato me bloquea, ¿no? Historia ficticia, eso no pasa. Entonces, ¿qué le digo yo? ¿Sabes qué? Quiero correr un job que se va a llamar Build Deploy. ¿Qué es lo que hace? Me dice el clima, güey, porque se llama Build Deploy, entonces, no sé, ¿para qué me preguntas, güey? Tiene que ser verboso. Y le digo, ¿sabes qué? Quiero que corras usando un bash para ejecutar las instrucciones, porque tenemos diferentes consolas, no sé, PowerShell, por favor, por amor a ustedes mismos y a la humanidad. Y le digo, por ejemplo, en qué tipo de directorio quiero trabajar, ¿no? Le digo, si están diciendo que voy a entrar a este proyecto que se llama Module Federated Libs, no me interesa lo que haya en otro proyecto, no me interesa entrar, a menos que, por ejemplo, sean proyectos que están ligados, porque luego pasa de que dividimos un proyecto muy grande en subproyectos y usamos herramientas como TurboRepo para poder generar y construir el proyecto, ¿no? X. Y finalmente, tenemos la parte de los steps, ¿no? Ya me dijiste dónde debo de correr, cómo voy a correr. Yo no, o sea, correr de la máquina, porque obviamente yo no corro, güey, o sea. Y tengo los steps. Obviamente aquí hay un checkout que me lo copié de Stack Overflow. Y es como de que dices, ¿sabes qué? En esta parte hay actions que también son como pequeñas instrucciones o módulos que dicen qué es lo que voy a hacer. En este caso este es un checkout y me trae la información del código, o sea, me trae la última versión, porque esto no ocurre después de que ya pasó. Es como, ya pasó, ok, ahora tengo que hacer esto. Aquí tenemos una parte de install, que es la parte de la instalación. Se instalan los paquetes de npm y obviamente pueden declarar variables de entorno. Y al final, por ejemplo, también podemos hacer uso de ifs para decir, oye, si tienes este evento, por ejemplo, yo no necesito hacer la parte del build si no es un pull request. No me interesa. Y pues ya finalmente es como de que, bueno, si es un push y fue sobre master, tienes que hacer un release, porque normalmente así funciona el flujo de software y quién soy yo para andar diciendo que eso está mal, ¿no? Así solo hacen los proyectos open source, así lo hizo mi padre, de su padre, de mi padre, el padre de mi padre antes de ser su padre, y en fin, esa es una tradición, creo que fue Maluma quien lo implementó, entonces, y pues obviamente aquí ciertas cosas, ¿no? Entonces, ese es el tipo de cosas, como les dije, hay ciertas consideraciones técnicas que debemos tomar de que estás usando un monorepo o estás usando un repositorio normal. Cuando es repositorio normal es más fácil porque pues todo hay, ¿no? Y pues también la parte de reusabilidad, ¿no? De que podemos a través de GitHub empoderar a nuestra organización porque podemos reutilizar ciertos workflows. Por ejemplo, ¿quién de aquí sabe que es un gatekeeper? No es un portero. ¿Gatekeeper? ¿Nadie? ¿Gatekeeper a la una? Güey, no mames, estaba donde yo trabajaba, güey, así lo tenía, güey, no mames. Bueno, de acuerdo. Estos gatekeepers son como esos cadeneros de antro, pero vigilan ciertas cosas, como por ejemplo, que estén corriendo ustedes, o por ejemplo la cantidad de coverage, ¿no? Que es como de, pinche vato, güey, le bajaste de 80 a 40, pues no hay pedo, güey, tú mételo. Entonces, GitHub Action nos permite meter esta clase de gatekeepers para que los procesos no continúen corriendo, ¿no? O inclusive también saltárnoslos, ¿sí? Entonces, bueno. Y pues esto lo iba a poner antes de que comiéramos porque pensé que iba a ser antes de comer, pero pues igual se ven chicos unos tacos, güey. Pues no hay pedo, ¿no? O sea, qué chido que todos se rieron, porque normalmente siempre prometo eso en las pláticas, o sea, o aprendes o te ríes. Sí. Si puedes hacer ambas estás genial, pero pues mínimo hay una, ¿no? Entonces si me decían que no, a todo el mundo iba a poner esto, así como... Entonces sí, ahora sí vamos a ver una pequeña demo. No va a ser tanto como la del Dani, porque al chile me da un chingo de huevo escribir. Es como he estado escribiendo código todo el día, no quiero venir a escribir más código aquí. Pero voy a hacer un commit y vamos a ver, ¿alguien de ustedes se entretiene cuando la lavadora así como no tiene nada que hacer? Bueno, más bien sí tienen un chingo que hacer, pero no quieren hacer y prefieren ver la lavadora cómo está lavando y así como de, güey, debió haber estudiado otra cosa. ¿Por qué no nací en una familia rica? No? Entonces vamos a ver una pequeña demo. Bueno, esta ya lo analizamos, entonces ya no hay pedo, ¿no? Entonces vamos a ver una pequeña demo. Acá está. No, güey. Está bien, güey. Es el pedo cuando le das algo caro a alguien que no lo sabe usar, güey. Entonces yo tengo una biblioteca que se llama React Hooks. Y es como, también para que vean que no les miento, es que ya tenía abierta la pestaña, güey, pero pues alguien me dijo, no, vete para acá, güey, y es como de, no, yo no les ese pedo, y, no, pues de pedo no necesitas ver, güey. Entonces, a ver, si muevo esto para, ya, pues, que estúpido soy. Entonces, si me muevo para acá, y me voy aquí al navegador, entonces, por ejemplo, aquí van a ver algunos workflows que han estado corriendo, ¿no? Ahorita voy a lanzar uno. Todos pongan mucha atención, ¿eh? Es como de que, esto es como magia, güey. Van a creer que ven algo, güey, pero en realidad no están viendo algo y les estoy sacando la cartera mientras... Entonces, confíen en mí, güey. Confíen en mí, por favor. No sean como mi crush. Ay, debe haberlo añadido desde antes. Okay. Estoy añadiendo un archivo dummy, no lo debería decir, pero nadie usa esta madre más que yo, entonces me va mal. Entonces, ok. Les dije que se venía Loñe. Está chido decir haciendo las traducciones, ¿no? Pero se la pongo bien complicada. Voy a usar puro pinche. Bueno, aquí es importante, esto es muy importante. Yo uso una herramienta que se llama Semantic Release. Es una herramienta que usa algo que se llama commit semántico, que básicamente lo que te dice es, güey, cuando hagas un cambio, especifica en cierto formato qué chingados es, güey. No me importa, es como de que all this change, o de que some stuff, como de que, güey, eso no me dice ni madre, ¿no? O sea, mi código está lleno de eso, pero ustedes no lo hagan. Entonces yo le voy a decir aquí que estoy desarrollando una feature, porque no es un bug, es una feature. Entonces, no, mejor le voy a poner que estoy haciendo un fix, no me quiero bien tan culero, güey. Entonces, aquí le voy a poner fix. Y, sí es cierto que no se ve, ¿verdad? Sí. No sé. ¿Más o menos? ¿Quieren unos lentes? ¿Quieren que se acerque la pantalla, güey? Pueden, si quieren, pararse, güey, y verla acá, güey, no pedo, Ok. Y le voy a poner test porque, bueno, no, porque tengo un linter que me dice que tiene que tener cierta test 4G. Sí, eso me pasa por querer hacer desarrollo de software bien, o sea. Sí. Bueno, sí, esta madre usa no por debajo. Pero... Y ahora voy a hacer un push, ¿ok? Push, que se vaya Listos, ok, antes de hacer esto, porque esto está medio extremo, güey, crucen sus dedos de las manos, porfa, todos crucen sus dedos. Quiero ver los que son los dedos, déjame estar crúzalos así, güey, crúzalos acá y cruza los pies si puedes, güey. Y después dice, la banda me respalda, güey.
Pinche reumatismo, güey.
Putiza. Ya, güey.
Ahí está, ya.
¡Ay, qué pendejo! Le di que recargara. Ahí está, güey. Está corriendo, güey. Está corriendo el viento Freud. Está haciendo el checkout, güey. Está instalando, güey. Vamos, güey. Así como esto es tan interesante como la Fórmula 1, güey. Vamos, así. Do it. Viene corriendo Arabella. Ok, casi, güey. Se va al testing. No mames, pasó porque no tengo el código ahí, entonces me pedo. Está construyendo. Está liberando, ya está preparando. No entiendo lo que sigue, pero. O sea, huevo, ya tengo la versión 1.3.1, güey. Y ya, güey. Todo se lo debo a mi navaja y a la cruz que se fue. Entonces, ahora, esto dices, güey, está con madre, está chingón. Ahora, el único detalle es que hay algunas cosas que se pueden mejorar, ¿no? Ya les había enseñado como de que, pues literalmente todos mis flujos son similares, tienen los mismos steps para hacerlo, ¿no? Pero hay ciertas áreas de oportunidad. Podemos hacerlo mejor, definitivamente, ¿no? Y pues ya no nos queda aburrir y básicamente ¿qué es lo que podemos hacer? Es agregar caché. Por ejemplo, esta parte de los módulos o esas cosas que usan esta madre, este pinche lenguaje que vale madre, ya va, sí. Que le quedas como que usa Maven y no sé qué otras cosas. Ese tipo de cosas pues se pueden cachar porque son cosas que casi nunca cambian y eso incrementa la velocidad de nuestros builds, ¿ok? Al final la parte de los pipelines es, no necesariamente todos tienen que ser rápido, pero entre más rápido hagas un release mejor, pero pues también está la parte como de que hay veces que por reutilizar o usar caché o no tener ciertas políticas te puede salir contraproducente, ¿no? Adicionalmente, por ejemplo, también podemos usar artefactos, que es como de, bueno, ya cuando construyes cierta pieza de software, puedes compartirla a través de steps, a través de jobs, porque los jobs es como si corrieran como en un sandbox, o sea, en una máquina por separado. Y entonces con los artifacts es como de que podría separar, hacer varios jobs y compartir artefactos entre ellos para que al final, pues, obtener el resultado, ¿no? Una cosa que se llama Matrix, y está mejor que la 4, obviamente. No, vale, todo está mejor que la 4, entonces es que pinche HBO peor. Entonces, por ejemplo, cuando ustedes hacen, los que han hecho software, díganme, bueno, sí, pero los que han hecho software para compartir a otros, compartir al público o algo open source, vamos a ponerlo así. Sí, cierto, ¿verdad? Si no me pagan, no lo hago. Ya me acordé. Bueno, hay personas que sí lo hacen. Bendita sea. No, gente que se pone la camiseta y que trabaja en una empresa que la adquirió cierta compañía. Dynamics. No, lo que tratas de hacer, por ejemplo, cuando tienes que dar soporte, por ejemplo, a varias versiones de Node, dices, oye, pues, ¿cómo pruebas eso? Es como voy a tener los mismos steps para Node versión 12, 14, 16, y entonces lo que haces es crear una matrix. Que es decir, güey, si existo, no. Es creas una matrix donde instalas varias versiones de Node y se corren los mismos steps para asegurarte que puedas brindar soporte a ese tipo de software, ¿no? Inclusive también podrías tener una matrix que pruebe Node versión 12, 14, 16 y decirle que pruebe en sistema operativo, por ejemplo, en Ubuntu, pues, viaje confiable, y en Microsoft, ¿no? Y dices, oye, o algún otro sistema operativo que tenga disponible GitHub Action, y pues 2x3, 6, entonces va a correr 6 procesos para probar eso, ¿no? Bastante lento, sí, pero asegura que tu producto sea estable. Y la parte de resolver workflows, por ejemplo, ¿se acuerdan que le mencioné esto de gatekeepers? Siguen sin ser los porteros, ¿eh? Entonces, cuando tu organización está creciendo, tienes que meter forzosamente políticas, porque al final somos desarrolladores y hay cierta gente que mete software y empiezan a meter software y dices, la calidad del código puede llegar a bajar porque no tienen ciertos procesos estandarizados. Entonces, con Reusable Workflows y algunas otras cosas como templates que provee GitHub Actions, bueno, en sí, GitHub, puedes empoderar a tu organización y hacer que los trabajos sean más fáciles, porque cuando corriges en un lugar, corriges en todos. Obviamente, eso también es una amenaza. Y créanme que GitHub no me está pagando. Ojalá lo hiciera. Así de que cuando alguien diga Workflow, me va a caer 10 pesos. 10 pesos que no, pues ya no alcanza para nada, güey, pero... Y entonces, pues, básicamente, eso es todo, amigos. Preguntas, tranquila para contrataciones, 15 años, también fiestas, despedidas de soltero. Preguntas, dudas, ¿quedaron? Qué bueno, ¿no? Ah, qué chingón.
Bueno, vamos a implementar un GitHub Actions ahorita, from scratch. Saquen sus máquinas.
Si no tienes celular, no hay problema, ahí les habilité un sitio para que empiecen a escribir.
¿Preguntas? ¿No? ¿Nada? Qué chido, ¿no? Bueno, siempre es grato tener a Joel. Gracias, Joel.
¡Bravo!
Joel estaba muy pacíficamente, él estaba muy feliz pescando jaivas en Veracruz.
Hablando con Aquaman y otros tíos.
Pasando sus ratos y tomando juntas desde su delfín.
Debajo del mar, no lo sé.
Pero nos lo trajimos justo para el Meetup y nos lo vamos a llevar a Colima.
¿Es correcto?
El fin de semana, si alguien está interesado, pueden asistir. Vamos a estar con la comunidad de codificadas.
Su aniversario.
Es su aniversario de la comunidad de codificadas en Colima. Y nos vamos a llevar a Joel para allá. Va a presentar con su guayabera de Pokémon. Entonces, si alguien quiere ir a ver la elegancia real de un verdadero veracruzano, va a ser en Colima.
Sí, voy a estar hablando de patrones de diseño y otras cosas que estoy implementando. Y cómo combatir nuevas técnicas.
Los frontend conocen patrones de diseño.
Entonces,
mi patrón me dice, güey, diseña esto y yo lo hago, güey. ¿Cómo funciona así o qué?
Hablo en Photoshop,
Photoshop acá.
Ok, gracias a todos por asistirnos, por venir, gracias por el tiempo que nos dedicaron, gracias por comer tacos. Todavía hay más tacos. Ok, English. Thank you everyone for coming, thank you everyone for eating tacos, thank you everyone for listening to us on the internet. We have still like 2,000 people around there. There's still beer, there's still tacos. Lydia did say that we can stay here until 4 of the morning, 4 a.m.
If you're hired.
Por el equipo, güey.
So we have still time, so you can talk to each other, you can know people around here. There's still tacos, yeah, I have already said that. But one another thing, I want to do some public commercials. DevOps.
¿Cuándo?
DevOps.
Julio 16, DevOps Guadalajara vuelve a las andadas. En el edificio de enfrente, con el 16, prácticas por confirmar. Y podemos buscar en el grupo de Facebook, DevOps GDL, o en Twitter, DevOps GDL también, ahí estaremos dando las noticias.
Y Java User Group.
No saben.
No, los chavos.
23 de junio, los esperamos. Lugar por confirmar, pláticas por confirmar. Chingo de regalos, ya saben.
Y ¿cuándo? 23 de junio. 23 de junio. 16 DevOps GDL, 23 Java User Group. Spoilers rápidos, estamos, así es, estoy hablando de más, siempre lo hago, pero estamos planeando el Java Dev Day de este año y el JCOM. Entonces ya están en pláticas, estén atentos a nuestras redes, etc. Java Dev Day va a estar relativamente limitado.
Última, también estén atentos a nuestras redes, vamos a celebrar el aniversario de la U. Vamos a querer acceso por la ventana de Instagram.
¿Cuántos años? ¿14? ¿15?
14, dijo 13, 10, pero 13, 14.
Oh, ok, y eso, 14 años Peter Brown, el aniversario de la U.
No es seguro, pero vamos a ver todo eso se puede ver para cuántas personas.
No se puede. Okay. Acceso limitado, entonces estén atentos a redes, compren sus boletos. Java Dev Day también va a ser limitado, entonces nada más vamos a tener un tope, creo como de 100 asistentes, entonces también estén atentos. Estén atentos por si quieren asistir a Java Dev Day y JConf, no creo que tengamos límite, entonces Estén atentos también a redes. Ahí va, que se vea. Gracias a todos. Allá hay chelas, allá hay comida. Todavía no nos vamos si quieren conocer a la gente. Ahí está el Orle, ahí está el Fer, ahí está Eric, ahí está Basil. ¿Otra vez? Ok. Ahí está el Orle. Ok, bueno. Gracias. Besitos.